Welcome back. This is Mrs. Thompson. We are looking at lesson 4.1, which is the prime factorization of monomials. Now, first thing you need to know is you should be filling in your notes. This is also in your book on page 178. And you also see page 177 is where you're going to see prime factors and prime. What is a monomial? It is a number, or it's a variable, or it's the product of those. Remember, the word product means to multiply, or it is the product of a variable and a number. So, if you want to think of what you might see for a monomial, it might be something like 4xy. It could be 2x squared y to the third. It could be a negative 1/3 xy to the fourth. All of those have a number and a variable with them. What's a factor? A factor is one or more numbers that will multiply to give you a given number. A lot of times if you think of factors of 6, the factors of 6 are 1 and 6 and 2 and 3. Remember, a factor is what you multiply to get the given number. A factor is always going to be smaller than the number that you're starting with, or the same. So you notice it can't be bigger for a factor. It's going to be that number or smaller. A prime factor is when you're talking about whole numbers that are greater than 1. And really our first prime is 2, and then you would have 3 and 5 and 7. And sometimes people go, oh, it's the odds. It is not, because it's not 8, it's not 9. The next one is 11. And remember, the key thing about prime factors is that the only factor that you're going to have, the only factors, are 1 and itself. And if you think about the numbers listed, you can see that. The prime factorization is when you would show the numbers that multiply. So if I'm looking at the prime factors of 10, the prime factors would be 2 times 5. If I'm looking at the prime factors of 12, the prime factors of 12 are 2 times 2 times 3. 4 times 3, 2 times 6, but the prime factors are written out this way. Expanded form just means that you're going to show what you multiply. So right up above, that would be expanded form. Show what you are multiplying. You're going to see some factors, something like 12, if you put this in your notes, x squared y. Well, 12x squared y, when I look at that, is going to be 12, or 2, times 3, and another 2, 4 times 3, and then I have 2 x's, so I write out x times x, and then y. On the bottom, would you please put up that first page, would you please write example 4, factoring monomials, and write out 24xy cubed. If you need to pause the video, please do so. If we're going to write out the prime factors, now some of you might have remembered like the Korean method where you did your prime factors and you said, oh, 2 goes in here and it goes in 12 times, and 2 goes into 12 and it gives me a 6, and you could have done it that way. Others of you might want to just list your prime factors. So we know we have 2 times 2 times one more 2 and a 3. So whichever way you chose to do that. And now we are going to write out all the x's and y's. I only have 1 x and I have 3 y's. Remember, y to the third is 3 y's. This is our expanded form. So you may be asked tomorrow towards the beginning, after we've done some homework questions, to write out for a quiz to do expanded form. How do we factor this one? Oh, this one's a nice and easy. 5 times a times b. Please try to write out the prime factors of 20 and t to the third. So when you come into class tomorrow, I will see this written out. How many t's should we have? If you look at this. Should have 3 of them. And then I need to see the 3 numbers before that you are going to multiply. And then I should see the 3 t's. Also, I would have you do letter C, 27w to the third, z to the second, and we will check that tomorrow in class. If you turn to the next page of notes, we want to look at lesson 4.2. What is a common factor? A common factor is a factor that two things have in common, two numbers have in common. So when we start talking about our greatest common factors, a common factor is just a factor that two numbers have in common. Or it could be two monomials have in common. So a factor that two numbers have in common. What is the greatest common factor? It is the largest, if we think of it, factor that is common to both. We're going to do some examples in just a minute to help you out. Sometimes there might be three numbers. So to both numbers or both monomials. Now, the key thing you have to be careful for is that when you look at the numbers, a lot of times it's the biggest factor. But when you look at the variables in a monomial, key thing you have to look for, it is the smallest exponent that is common. So, I'm going to give you an example here. Common exponent might be, if we are thinking about x squared and x to the third. What is the greatest common factor? The greatest common factor would be x to the second, because they both have two x's. How do you find the greatest common factor? First thing you want to do is write out your prime factorization. So you're going to write out, and if you pause the video, I'm going to put these up and you can copy them. So again, if you need to pause the video or go back, first step, write prime factorization of each expression. Second step, find the common factors. And our third step is to multiply those common factors. We're finding the product. We have one more definition. So as you look at these, again, you may need to pause this and you can write these in. And when are two numbers relatively prime? Well, they're relatively prime when they have no common factors. So if they have no common factors, that would be, if we're thinking of the numbers 7 and 20, are going to be what's called relatively prime. They don't have anything in common. Whereas 3 and 15, 3 is a prime number, but these two are not relatively prime. The reason they're not relatively prime is that they actually have, if we are looking at that, I can't spell that right, relatively prime, and the reason that they are not relatively prime is that they have a common factor of 3. 3 is a common factor of these two numbers. Now, we're going to take a look at some examples. So, please write on the bottom of page 2 in your notes, right below 4.2, find the greatest common factor. You might want to write that out, or you could put GCF of 15x to the cube and 10x to the fourth. First thing you're going to do in your notes, and if you need to pause it, you'll put down 15x cubed. If we are looking at 15x cubed, and what we want to do now is we want to see the prime factors. The prime factors are going to be 3 times 5 and then 3 x's. This is what you may be seeing in your quiz today, where I ask you to write out the expanded form. Well, what is 10x to the fourth? 10x to the fourth is 2 times 5, and then there are 4 x's. What's our common factor? Well, they both have a 5 in common. So our common factor is 5. They also have 3 x's. So here I have 3 x's and here I have 4. Remember we said we take the smaller of the numbers, so x to the third. So our greatest common factor is 5x to the third. If you would like to pause the video and try it right now, listing your prime factors of each of these, you're going to see I'm going to do 9 and 10, and then you will do 11 and 12. So pause the video. As you look, 3a, well, that's already written as 3. We can write that as 3 times a. 21 is 3 times 7 times a. What do they have in common? They both have a 3, they both have an a, and sometimes if you line them up like this, our greatest common factor is 3a. When I'm looking at 16, some of you might recognize in 16 and 12 that they actually have 4. So maybe I don't want to do prime factors, but if 16xy squared, I might write that as 4 times 4, x and y times y. 12x squared y, I might write as 4 times 3. I have 2 x's and a y that I'm multiplying. What do they have in common? They both have a 4. They both have one x and they both have one y. So my greatest common factor is going to be 4x and y. The smallest power of x is x to the first, same with y. Please do 11 and 12 now. I am not going to show those to you. I would like you to write out the prime factors. So I should see the prime factors written out. And if you again wanted to find something common, circle that and then tell me your greatest common factor. I should see that for both 11 and 12 when you come into class tomorrow. What is a multiple? If we are looking at multiples, really quickly, a multiple is just, if we think of factors of 6, that was 1, 6, 2, and 3, always smaller. Multiples get bigger. Multiples of 6 are 6. 6 times 2 is 12. 6 times 3 is 18, then 24. Multiples are that number or larger. So when we're thinking of multiples, it is that number or it is going to be larger. Or I'm going to multiply by a number greater than 1 to get the next multiple. What is our least common multiple? If we're thinking of the least common multiple, it's the smallest, if we are thinking about this, the smallest common multiple. So when we look at 6, 12, 18, it would be the smallest of these that they have in common, the smallest multiple they have in common. Now, again, with the variables, it gets tricky. When you have a monomial and you have variables, for the variables, this time you're going to choose the largest exponent, and you want to make sure you list all variables. So only if the x is in one of them, you want to list it, even if it's not with all of them. So if we are finding the least common multiple of 2 or more, first we want to factor our expression so we can see our factors. Circle, then what we're going to do, so I'm going to write these and you can pause it and then you can copy it. So how do you find the least common multiple? You might want to stop the video. You're going to factor each expression using exponents, circle the greatest power of each factor, then find that product of what you circled. So here is an example that you're going to put on the bottom of this third page of notes. 6x squared y and 9x to the fourth z. Here are my prime factors of 6 using exponents, and 9 is 3 squared times x to the fourth and z. What is going to be my least common multiple? Well, if we are circling, I have to have a 2. They both have a 3, but I want to circle the biggest power, 3 squared. They both have an x. I want the largest power, x to the fourth. They both have a z, and they have to have a y, because neither z or y is common. So if I'm looking at my least common multiple, I have to have a 2. 3 to the second, x to the fourth, a y, and a z. That means 2 times 9, which is 18, x to the fourth, y, z is my least common multiple. Different than our greatest common factor. So here we're going to put 2 to the third. 3 2's multiplied together give us 8, and x to the third. 20 is 4, or 2 squared times 5, and x to the 7th. What do they have in common? Well, they both have a 2, but the largest power is 2 to the third. They both have an x, the largest power is x to the 7th, and only one of them has a 5. So I have to have, in my least common multiple, 2 to the third times 5 times x to the 7th. Please try B and C, and I'll see you tomorrow in class with those completed, and we'll do a worksheet.